Hello, hello. So, hello everyone, good morning. Good morning. This is lecture number 3 of vector analysis. So, if you haven't watched the previous two videos, so kindly go through that because this is a continuation of the previous two classes, right? So, if you haven't watched those two videos, go through that, right? Okay. So, this is lecture number 3. So far what we did in vector analysis is that in the very first video, we have discussed the syllabus and then we have analyzed the last 10 year question papers. After that, we have introduced what is meant by gradient. We have seen some problems based on gradient. And in the previous class, we have defined what is meant by level surfaces and a tangent and a normal to a level surface, right? So in the previous class, we have did some problems that define the equation of tangent plane and normal line to the surface at some point, right? Okay. So we will do some more problems based on that. After that, we'll be moving on to the next concept called directional derivative. After that, we'll be moving on to what is meant by divergence and curl, right? Okay. So we'll continue. I think everything is fine, right? So my voice is audible. Okay. So we'll continue. I think in the previous class we did one problem based on find the equation of tangent and normal. And then I have given you one problem for exercise, I think. So we'll start with the second problem. And in the previous class I have given you one note, right? So what that note says is angle between the two surfaces at some point is the angle between the normals, right? We have just go through the previous notes. After defining the equation of tangent and normal, I have given you one note. What that note says is angle between the two surfaces is the angle between the normals, right? So go through that note. So we're going to do one problem based on that, right? Okay. So angle between the two surfaces. Okay. So recall. Right? So this we have yesterday only I given you this note. Okay, we will recall this. The angle, the angle, the angle between the two surfaces at a point is the angle between the normals normal to the surface at that point, right? At that point. Or I'm going to give you one more formula also. So if they will give two surfaces, they will ask you to find angle between them. So for the first surface, you find the normal line, and for the second surface, you find the normal line, and you have two normal line now. You know angle between the two lines formula, right? That you can do one method, or you can also use the method the angle between the two surfaces. Let us say phi1 and phi2, right? Suppose if they given two surfaces phi1 and phi2 or f1 f2, the angle between them is given by del phi1 dot del phi2 divided by modulus of del phi1 into modulus of del phi2, right? So you can also use this formula. I'll do problem based on both the formula, right? Both are going to give you the same answer. So you can use any one of them, right? So del phi1 and del phi2 at that point, right? Angle between two surfaces at some point B. Del phi1, del phi2 at phi divided by modulus of del phi1 into modulus of del phi2, right? You can use any one of these. So we'll do problems, right? So I'll do problems based on both the formulas. So whatever is convenient for you, you can use them, right? Okay. So I'll start with second problem. The previous class we have did one problem based on equation of tangent and normal. So find the angle between the surfaces. To find the angle between the surfaces, find the angle between the surfaces, x square y square plus z square is equal to 9 and z is equal to x square plus y square minus 3 at the point 2 comma minus 1 comma 2, right? So first what we will do is we will do in this formula, and then we will do in this formula. Both are going to give you the same answer only, right? Okay. So first what we will do is we will use this method. The angle between the two surfaces is the angle between the normals. So first what we will do is we will find the equation of normal line, right? So let us take a first surface. So the first surface here is phi1. Phi1 is x square plus y square plus z square minus 9 is equal to 0, right? So this is the first surface. So what is the equation of a normal line? So it is capital X minus X divided by dou F by dou X. Okay, let us write this as so okay, instead of F, I'll write phi1, right? Because we are using the symbol phi1 here. So dou phi1 by dou X, capital Y minus small y divided by dou phi2 by dou Y, capital Z minus small z divided by, sorry, dou phi1 by dou Z, right? So this will be so we will find dou phi1, dou phi2, we will find dou phi1 by dou x, dou phi1 by dou y, dou phi1 by dou z at the point 2 comma minus 1 comma 2. So what is here? Here phi1 is x square plus y square plus z square minus 9. So dou phi1 by dou x, right? So dou phi1 by dou x will be 2x, and okay, we will find a gradient at this point, right? Instead of this, we will find grade phi. So grade phi1 is dou by dou x of dou phi1 by dou x, dou phi2, dou phi1 by dou y plus dou phi1 by dou z. So this will be, you differentiate with respect to x. So we will be having this will be I vector, right? I vector, j vector, k vector. Okay, so you differentiate with respect to x, so we'll be having 2x I vector with respect to y, 2y j vector plus 2z k vector. Now at the point 2 comma minus 1 comma 2, so gradient will be 4i vector minus 2j vector plus 4k vector, right? So you compare this with this, so that means this implies dou phi1 by dou x will be 4, dou phi1 by dou y will be minus 2, and dou phi1 by dou z will be plus 4, right? So therefore, what is the equation of normal? So it will be capital X minus, this is small x, small y, small z, right? So capital X minus 2 divided by dou phi1 by dou x. So dou phi1 by dou x is 4, capital Y minus small y, so it will be plus 1 divided by minus 2, capital Z minus small z divided by dou phi1 dou x. So this is the equation of first normal line, right? This is the equation of first normal line. Now we will find the equation of second normal line. So what is phi2? So phi2 is x square plus y square minus z, right? I'm just bringing this inside, minus z minus 3 is equal to 0. So what is the equation of normal line? X minus x divided by dou phi2 by dou x, capital X minus small y divided by dou phi2 by dou y, capital Z minus small z divided by dou phi2 by dou z, right? Now here we will find grade of del phi2. This is dou phi2 by dou x I vector, dou phi2 by dou y j vector, dou phi2 by dou z into k vector. So with respect to x, so this will be 2x I vector with respect to y. So 2y j vector with respect to z, so it will be minus 1 into k vector, right? Now at the point 2 comma minus 1 comma 2, so this will be 4i vector minus 2j vector. Here there is no z term, right? So this will remain as it is, right? Okay. So 4i minus 2j minus k, right? 4i minus 2j minus k. So this will be capital X minus small x is 2 by 4. So that means this implies our dou phi2 by dou x will be 4, dou phi2 by dou y will be minus 2, dou phi2 by dou z will be minus 1. So this will be small okay. So this will be plus 1 divided by dou phi2 by dou y is minus 2, divided by dou phi 2 by dou x1, right? So this is the equation of the second normal line. Now we need to find the angle between the line, right? So the angle between we know angle between two lines formula, right? So here the two lines are in Cartesian form, right? The two lines are in Cartesian form. This is the equation of line in 3 dimension. This is the equation of line in 3 dimension. Equation of line in 3D, we have equation of line in 2D. We have vector equation and we have constant equation in 3 dimension. So we know that if two lines are in Cartesian form in 3 dimension, right? Let's say the first line is x minus x1 by a1, y minus y1 by b1, z minus z1 by c1. This is the first line. And second line is x minus x2 divided by a2, y minus y2 divided by b2, z minus z2 divided by c2. Angle between them, right? The angle between the two lines is given by a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square b2 square c2 square, right? This is the 12th standard formula. The angle between the two lines in 3 dimension if they are in Cartesian form, right? Similarly, you can see we have two lines, right? We have two lines. So this is our a1 b1 c1 and this is our a2 b2 c2, right? So the angle between the line 1 and 2 is given by the angle between cos theta is equal to, right? Cos theta is equal to, so cos theta is equal to a1 a2 b1 b2 plus c1 c2 divided by root of a1 square b1 square c1 square, right? The angle between 1 and 2, the angle between 1 and 2, right, is given by, so cos theta is equal to, so we have what is our a1 b1 c1 and what is our a2 b2 c2. So a1 b1 c1 is 4 minus 2 4 and a2 b2 c2 is 4 minus 2 minus 1, right? So a1 a2, so a1 a2 is 16 plus b1 b2, so which is plus 4 plus c1 c2 is minus 4 divided by root of a1 square b1 square c1 square. So 16 plus 4 plus 16 into root of 16 plus 4 plus 1. 16 plus 4 plus 1, right? 16 plus 4 plus 1. So I think simplify this, you will get the answer. So this is root 36, right? So we have cos theta is equal to, so 16 plus 4 is 20, okay, this will be 16 divided by, this will be 6, right? So root 36, and this will be root 21. This will be root 21. So I think we will cancel. So 2 3s are 2 8s are. This implies theta is equal to cos inverse of 8 divided by 3 root 21 is the angle between the two surfaces, right? Is it clear? Very simple, right? You find the equation of normal between the two lines and you just find a1 b1 c1 a2 b2 c2. So a1 b1 c1 is these three, a2 b2 c2 is these three, and you apply the formula here, you can find the angle between the two surfaces, right? Or you can also use this formula also, right? Del phi1 dot del phi2 at this point divided by modulus of del phi1 into modulus of del phi2. If you use this formula, you don't need to find the normal surfaces, right? Okay. So we move on to the third problem. Find the angle of intersection at 4 comma minus 3 comma 2 of the spheres x square plus y square plus z square 29 and x square plus y square plus z square plus 4x minus 6y minus 8z minus 47 is equal to 0, right? How that 4i plus 2j plus 4k come? See, I'm just substituting this point x, y, z. Right, so x is 2, y is minus 1, z is 2. So x is 2, so 2 2s are 4, y is minus 1 and z is 2. So we are finding at this point. Here also at this point. So this will be x, this will be y, this will be z. So substitute this x, y, z to be 2 minus 1, 2. Okay, so similarly, we will find angle between the two surfaces. So you can find a normal or you can also use this formula. So let's try this formula, right? Del phi 1 dot del phi 2, or you can also find the angle between the normal. So we know that the angle between the two surfaces is the angle between the normals, or you can also use the formula that angle between the two surfaces is actually this is cos theta, right? Sorry, this cos theta is equal to, so you just change this, right? So it is cos theta is equal to, sorry, okay, so so we will use this formula now, right? Because just now we have did using this method, or you can also use the formula cos theta is equal to del phi 1 dot del phi 2 divided by modulus of del phi 1 into modulus of del phi 2, these two at the point P, right? So we'll use this. So here we have phi 1. So here we have phi 1, right? So they have given phi 1, phi 2, and we need to find at the point 4 comma minus 3 comma 2. So we have phi 1 to be equal to x square plus y square plus z square minus 21. So we will find del phi 1. So it will be dou phi 1 by dou x I vector, dou phi 1 by dou y j vector, dou phi 1 by dou z into k vector, right? So this will be dou phi 1 by dou x. So it will be 2x I vector now at this point, right? At the point 4 comma minus 3 comma 2, because we need to find del phi 1 and del phi 2 at this point. So at this point, so 2 into 4 is 8. So 8i vector, this will be minus 6j vector, and this will be 4k vector, right? So this is del phi 1 at this point. Now similarly, you find del phi 2. So phi 2 is x square y square z square plus 4x minus 6y minus 8z minus 47. So you find del phi 2. So it will be dou phi 2 by dou x I vector, dou phi 2 by dou y j vector, dou phi 2 by dou z k vector. So with respect to x, it should be 2x plus 4, right? So 2x plus 4 into I vector with respect to y. So 2y minus 6 into j vector with respect to z, 2z minus 8 into k vector. Now at the point 4 comma minus 3 comma 2, right? At the point 4 comma minus 3 comma 2. So what about del phi 2? So del phi 2 will be, so when you substitute 4 here, 2 4s are 8. So 8 plus 4 is 12. So it will be 12i vector. So when you put y to be equal to minus 3 here, so minus 6 minus 6. So again minus 12. When you put this z to be equal to 2, 2 2s are 4. 4 minus 8. 4 minus 8 is minus 4 k vector. This is our del phi 2. So we apply the formula directly. We can also find modulus of del P1, modulus of del P2, right? What about modulus of del P1? It is root of 64 plus 36 plus 16, right? Root of x square, y square, z square, 64, 36, 16. So this will be root 116, right? It will be root 116. Just back in a minute. Okay. So now you find del P1 and del P2. Okay. Now you find modulus of del P1 modulus of del P2. This will be root of 8 square plus 6 square plus 4 square, right? So there will be root 116. Okay. So what about modulus of del P2? Is root of 144 plus 144 plus 16, right? This will be root of, so 144 will be 288, 288, 294, this will be 304, right? So root 304. It's going very. Okay, so we'll do this, no problem. So now we'll find angle between them. So angle between them is cos theta is equal to del phi1 dot del phi2 divided by modulus of del phi1 into modulus of del phi2. Now what about del phi1 dot del p2? This will be 8i minus 6j plus 4k dot 12i minus 12j minus 4k divided by modulus of del phi1 modulus of del phi2, which is root 116 into root 304. Right? So to make a dot product here, 8 12s are, so 88, even 96, right? 96 minus minus will become plus, 12 6 are, it will be 72. 4 into minus 4 will be minus 16 divided by root 116 into 304. So this will be 96 plus 72 will be 98. 98 plus 70. 98 plus 70 will be 168, 152. So this will be 152, and this will be root 116 into root 304, right? So if you want, you can also take a square root here. So this will be, if I make a 2, so 2 5s are 10, balance 1. 2 5s are 10, balance 1. 2 8s are 16. 2 29s are. So this I can write this as 2 root 29, right? 29 is prime number. So 2 into 29. So 2 root 29. And again for 304. So 2 152, right? 152. And if you make 2 again, 2 7s are 14, balance 1, 2 6 are 12. And this should be 2 again. So 2 3s are 6, balance 1. 2 8s are 16, 2 19. So this will be 4 root 19, right? 4 root 19. So if we cancel this, this you will be having 2 into 4 is 8, and 8 ones are 8, balance. So if I cancel this, 4 3s are 12. Okay, 2 2s are 2 7s are 14, balance 1, 2 6 are 12, again 2 1s are 2 38s are, again 2 1s are 2 19s are, right? So we will be having 19 divided by root 29 root 19, right? This is the required angle. Or you can also write this 19 as root 19 into root 19 divided by root 29 to root 19. So these two will get cancelled. Therefore, theta is equal to cos inverse of square root of 19 by 29, right? This is the angle between them. Is it clear? So the angle between the two surfaces is the angle between the normals, or you can also use the formula del phi 1 dot del phi 2 divided by modulus of del phi 1 modulus of del phi 2 at the point P. Okay. Now we introduce the definition of directional derivative. Right? So directional derivative. Directional derivative the directional derivative of a scalar field f at a point P x comma y comma z in the direction of a unit vector in the direction of a unit vector a cap is given by, so df by ds is called directional derivative gradient of f at p dot a cap, right? So this has to be a unit vector, right? This has to be unit vector. So a cap, suppose if it is not a unit vector, means you can always make that as unit vector by dividing by modulus of that vector, right? So if it is not a unit vector means length has to be 1, right? Magnitude has to be equal to 1. So if it is not unit vector means you can always make that as unit vector by a vector by modulus of a vector, right? If you normalize that vector, it will be a unit vector. The directional derivative of a scalar field f at a point P in the direction of a unit vector a cap. So what we have is we should have a field f, right? We are finding the directional derivative at a point P in the direction of. So we have three things here, f, p, and we have one direction, right? We have one direction, and this direction has to be unit vector, right? This has to be unit vector. So if we have three things, I can find the directional derivative of that field at the point P, and it is given by del phi at the point P dot a cap, right? So dot a cap. So if I do one problem, it will be more clear for you. To find the directional derivative, so find the directional derivative of f of x comma y comma z is equal to x square y z plus 4x z square at the point 1 comma minus 2 comma minus 1 the direction of the direction of the vector in 3 dimension you will talk only directional derivative, right? So in 3 dimension you will talk about derivative as well as directional derivative. So if I say directional derivative means we are finding the derivative in the direction of some unit vector, right? So I'll give you more idea I'll give you more idea about this when we study divergence and curl, right? Find the directional derivative of this function of this point, the direction of this vector. Okay. So what is the formula? We need to find del phi at this and in the direction of this vector. So this vector is not a unit vector, right? Because if I take if I find the length of this vector, it will be not 1. It will be root of 4 plus 4 plus 1, root 9. So root 9 will be 3. So it is not a unit vector. So we will first what we'll do is so here. So first we will find del phi, right? So del phi or del f. Given f here, right? So del f. So it will be dou f by dou x into I vector, dou f by dou y into j vector, dou f by dou z into k vector. So dou f by dou x. So it will be 2x yz plus with respect to x 4z square into I vector. Now with respect to y, so x square z and this will be 0 into j vector. With respect to z, this will be x square y plus with respect to z, it will be 2z. So 8xz into k vector, right? Now at the point 1 comma minus 2 comma minus 1, because we need to find del phi at p. So this is a point p here at 1 comma minus 2 comma minus 1. So this will be x y z. So this will be x into y into z. So this will be 2. So we have 4 here. 4z square will be 4 again into I vector x square z. So 1 square into minus 1. So minus 1 into j vector x square y. So x square y will be minus 2. 8 xz. So 8 times x into z. So this will be 8i vector minus j vector. So minus 2 minus 8. It should be minus 10k vector. This is the del phi, right? This del phi at this point. Now we will find a cap. So they are given, you take this as a vector, right? You take this as a vector. A vector is 2y minus j minus 2k. You need to normalize this vector, right? Because it has to be unit vector. So what about a cap? So a cap will be a vector by modulus of a vector. So 2y minus j minus 2k divided by square root of 4 plus 1 plus 4. This will be 3, right? So root 9 will be 3. So this is a cap. Therefore, directional derivative is given by del phi at p dot a cap. So del phi, okay, del f, right? Del f. So del f is 8i minus j minus 10k dot a cap. So a cap is 1 by 3 2y minus j minus 2k. So we make a dot product. We will have 8 into 2 by 3. So it will be 16 by 3 minus 1 into minus 1 by 3 plus 1 by 3 minus 10 minus 2. So it will be plus 20 by 3, right? So this will be 37 by 3. So 37 by 3 is the directional derivative. Directional derivative at this point, right? Okay. And also what we can infer is if suppose if you are finding, suppose if you have a surface here and let's say this is a surface, right? And if you are finding the directional derivative at this point in the direction of some vector, right? The direction of some vector, you are finding the directional derivative. Suppose if this directional derivative is positive, means you can also say that it is an increasing function. In a single variable calculus, you would have known, right? If f dash of x is greater than or equal to 0, f is increasing. If f dash of x is less than or equal to 0, it is decreasing. If f dash is strictly greater than 0, it is strictly increasing. So here also, if your directional derivative and the direction is positive, means you can say that f is an increasing function in that direction. It is a very three-dimensional, very hard to visualize, but we are no other option, right? So we can also, this is an extra information that since directional derivative is positive, f is increasing in this direction, increasing function in this direction, right? This is how to find the directional derivative of a function at the point in the direction of some vector. So you find del phi at this point, you normalize this vector, make a dot product, you'll get the answer, right? Very simple. So I'll give you an exercise problem for you. Find the directional derivative of f of x comma y comma z is equal to x square minus 2y square plus 4z square at the point 1 comma 1 comma minus 1, the direction of the direction of 2i plus j minus k. Okay. I think you can do this problem now, right? So just take this exercise problem. Your answer will be 8 by root 6. So I'll do third problem now. So find the directional derivative of the function f is equal to x square minus y square plus 2z square at the point 1 comma 2 comma 3 in the direction of the line PQ, where Q is the point I comma 0 comma. Right? A very simple problem. So we need to find the directional derivative of the function f. So please take today's class, the first problem, second term. It's only minus 2j only, right? 4i minus 2j. So we are substituting y to be equal to minus 1. So 2 into minus 1 will be minus 2. So y small y is minus 1. So it will be minus of minus 1 will be plus 1. Dou phi 1 by dou y will be minus 2. Okay. So we need to find the direction derivative of f at this point. So in the previous problem, they are given the direction to be some vector. Here they are given direction of the line PQ, right? So we need to find in the direction of the line PQ. So very simple, right? So we need to find the direction of line PQ. So they are given f. So f is x square minus y square minus 2z square. Now you find del f. So del f is dou f by dou x into I vector dou f by dou y into j vector, dou f by dou z into k vector. Now with respect to x, it will be 2x I vector minus 2y j vector plus 4z k vector, right? Now at the point 1 comma 2 comma 3, this will be 2i vector minus 4j vector plus 12k vector. This is del phi. I don't know where I made mistake. Is there any mistake I have made here? Second term you written for. Anyone have any mistake in this problem? Is there any mistake in this problem? Second term you written for. Actually, I got a correct answer, right? This is the right answer. 8 4i plus 2j. No, here we have 1 only, right? Here there is no z term. Here there is no z term, so we should not substitute 2 here. This term is independent of z. We have only 1. So if you differentiate with respect to z, there is no z term here. So if you have z only, you need to substitute 2 in place of z. We have only 1 here, right? 1 into k. So that means there is no z term here, so you should not substitute 2. So we have only k. This is 1. Okay, so this is del phi at this point. Now we need to find what is our direction vector in the direction of the line PQ, right? So we need to find the direction of the line PQ. Now PQ is nothing but OQ vector minus OP vector, right? So if I write as question vector, PQ vector, PQ is nothing but OQ minus OP, right? OQ minus OP. Now what is OQ? OQ is the point, if I write it as vector, so Q is 504, right? So this is origin. Q is 504. If I write it as vector, we'll be having 5i vector plus 0j vector plus 4k vector, and OP will be, so OP. So P is, doesn't it here itself? What is P? 1, 2, 3. So P is 1, 2, 3. So if I write, this is Q. So if I write it as quotient vector, it will be I plus 2j plus 3k, right? I plus 2j plus 3k. Now OQ minus OP will be 5i plus 0j plus 4k minus I plus 2j plus 3k. So 4i minus 2j plus k vector. This is the direction now, right? In the previous problem, they have given the direction straight away. So this is our A vector now, right? This is our A vector now. 4i minus 2j plus k. So A vector is 4i minus 2j plus k. So normalize this. So A cap will be, so A cap will be A vector by modulus of A vector, right? So 4i minus 2j plus k divided by root of 16 plus 4 plus 1. So 4i minus 2j plus k divided by root 21, right? This is our A cap now. So therefore, the direction derivative is given by del phi at the point P into A cap. So del phi at the point P is 2i minus 4j plus 12k dot A cap 4i minus 2j plus k divided by root 21. So just make a dot product here. So 2 4s are 8. 4 into minus 2 is plus 8. This will be plus 12 divided by root 21. So 8 is 16. 16 plus 12 is 28. So we'll be having the rational derivative to be equal to 28 by root 21. Right, this is the directional derivative. This point. Okay. Now I'll give you one note. The directional derivative of f is maximum in the direction of grade f. Right, so you can see we are finding the directional derivative in this direction, where for example if we take in this problem we are finding directional derivative in this direction. We have got the answer to be equal to 37 by 3. And suppose if you take some other direction means you will have some other number, but the next question is when that number will be maximum. So that number will be maximum if you take the direction to be del phi itself, right? So the directional derivative will be maximum in the direction of grade phi, right? So grade phi, del phi both are same, right? So I'll repeat. So for different direction you will have different directional derivative. Directional derivative is a number. So for different direction you will have different directional derivative. So among those, at what direction you will have a maximum value for directional derivative? The answer will be in the direction of grade phi. Right? In the direction of grade phi, we will have the maximum value for directional derivative. Right? Yes. So we move on to fourth problem. So before that, I'll save this. The fourth problem is in what direction from the point 1, 1, minus 1 is the directional derivative of f is equal to x square minus 2y square plus 4z square, a maximum. Also find the value of this maximum directional derivative. Right? So in what direction from the point is our directional derivative is maximum? Also find the value of this directional derivative, right? Solution. So first we will find del phi at this point. So what is del f? So what about del f? So it is dou f by dou x I vector, dou f by dou y j vector, dou f by dou z into k vector. So this will be 2x I vector minus 4yj vector plus 8zk vector. Now at the point 1 comma 1 comma minus 1, this will be 2y vector minus 4j vector. This will be minus 8k vector, right? Now you need to take a cap to be equal to. So we know that directional derivative is maximum in the direction of del v. The direction of del v. So you take a vector to be the same, right? 2i minus 4j minus 8k, right? So in the previous problem they have given you some direction. Now you take direction to be same as del v. Now what about a cap? So a cap is a vector by modulus of a vector. So 2y minus 4j minus 8k divided by root of 4 plus 16 plus 64, right? 4 plus 16 plus 24. So 2y minus 4j minus 8k divided by root of 20 plus 64. This will be root 84, right? This will be root 84. Now you find okay, also find this value of this maximum directional derivative. In what direction is the directional derivative or it is maximum? Also find the value of this maximum directional derivative. Okay, so what will be the directional derivative? It will be df by ds. So it will be del phi dot a cap. So del phi dot a cap, right? So what is del phi dot a cap? So del phi dot a cap, okay, 2i minus 4j minus 8k dot 2i minus 4j minus 8k divided by root 84. So to make a dot product here, 2 2s are 4, 4 plus 16 plus 64 divided by root 84. So we'll be having 84 by root 84. So I can write this as root 84 into root 84 divided by root 84. So root 84 is the maximum value for the directional derivative, right? So directional derivative will be maximum in the direction of del phi. So you take a vector to be the same as del f vector, right? Del f vector. So I'll give you an exercise problem for you, right? I'll give you some exercise problem. Find the unit normal vector to the level surface x square y plus 2xz is equal to 4 at the point 2 comma minus 2 comma 3. You find the normal vector. After that you normalize that vector, right? So if you, for example, you find normal vector, take that as n. You normalize that, right? Okay. The next problem is, okay, if you want, I can also do this problem, right? So find the unit normal vector to the level surface. So x square y. What is the unit vector of a level surface at the point? It will be capital X minus small x divided by dou f by dou x, capital Y minus small y divided by dou f by dou y, capital Z minus small z divided by dou f by dou z. Now I'll do this directly. So this will be capital X minus 2 divided by, now dou f by dou x will be 2xy plus 2z. Now when you substitute this point, we will have 2 into minus 2 plus 2 into 3. So 2 2s are 4, 4 2s are 8. So minus 8 plus 6. So you will have this to be equal to minus 2, right? So we will have this to be minus 2, and this will be 2xz. This is 2xz. With respect to x we are doing, right? So 2xy, 2xy, 2xz, 2xz is question. With respect to x means we have 2z. Okay. Now similarly with respect to y, so this will be, what about dou f by dou y? So we will have x square, and this will be 4 z minus 3 divided by, with respect to z, so this will be 0, this will be 2x, this will be 4 again, right? Now you take this as unit normal vector, right? So let us take n vector. This is unit normal vector. So minus 2y plus 4j plus 4k. So if you have seen direction cosines and direction ratios of our channel, you would have known that this is a normal vector, minus 2y plus 4j plus 4k. Now you normalize this vector. So n vector by modulus of n vector. So you'll get the answer, right? So this is our n vector. You normalize this vector, right? Okay. So that's it. So we have completed this subtopic. So the next subtopic, what we will do is we will be. I don't want to give you more exercise. Okay, if you want some more examples, what I will do is I'll post in Telegram group, right? So in Telegram group, I'll give you some exercise problems based on this. So you can work out, or you can work out based on this. In the next class, we will be starting the next subtopic, which is divergence and curl. The topic that we are doing is gradient, divergence, and curl. And the next topic we will be moving on to divergence and curl. So based on that, we will be doing more problems on that, right? So all are very easy. The only thing is you need to remember the formulas, right? As of now, there are only very limited formulas. Gradient formula, and then tangent plane formula, normal line formula, and directional derivative formula. So those are the only 4 to 5 formulas that we have seen. And there is one note that the directional derivative will be maximum the direction of del phi, and angle between the surfaces is the angle between the normal, or you can also use the formula del phi 1 dot del phi 2 divided by modulus of del phi 1 into modulus of del phi 2, right? So you can use this formula. So next class we will be moving on to divergence and curl, right? Divergence and curl. So for some days there is no evening class, so I'll update if we have evening class in Telegram group, right? For some days there is no evening class. Okay, so thank you, bye. We'll see in the next class. Thank you.